For this one, guys, you need normal CDF, 4 arguments, lower bound, upper bound, mean, and standard deviation. Your lower bound will be the 1.82. Your upper bound will be 1,000 or 1,000,000. Mean is 0, standard deviation is 1 when working with Z, and then you can get the value. He gives you an access to a table if you want to do it. You can use the table. The table gives you the area to the left, and then you have to do 1 minus, but you really, guys, can disregard, just this link. You don't have to use the table at all. Okay. Next. You see, you won't do this and do this one as well. These are like 5 or 6 questions testing the same thing, and each one of you will get only 1 question. So it's not like you're going to get so many of those. Here is asking you to find the area in between 2 values. That will be a normal CDF from negative 1.5 to 1.6, and then 0, 1, and then you get the answer. Look, another one from 0 to 2.34. Here, probability of Z less than 0.86. So that means area to the left, which is normal CDF, negative 1,000 or 1,000,000, 0.8601. Greater than 2.76. In between, now X. For X, it's different. Your mean is going to be whatever the mean is given in the problem, or whatever the standard deviation is. So for this one, if you guys if you do this on the calculator, it's going to be this normal CDF. You're going to go to 77. You're going to put 84. Then you're going to put the mean, which is 90. And then you're going to put the standard deviation, which is 5. And then you get the answer. All right. Let's go to the next one. Let me clear here. This is another question with parts. He gives you the mean and the standard deviation. He asks you to find parts A, B, C. What's the probability that X less than 4? Let me just do one of them. That will be normal CDF, negative 1,000,000, 4, and then the mean is 4.8. And the standard deviation, guys, is 2.3. And then you find this probability. Then the next one is between 4 and 6, then more than 8. Then the last part, he asks you, are there any unusual events? Well, an unusual event if the probability is less than 5%. You notice all those answers, guys, here are more than 5%, so none of them are unusual. Okay. Next. Another question similar to the one that I just talked about. Okay, here, this is the second feature in chapter 5 that you will be using. It's inverse norm. You need an area to the left, and then if you're doing a Z here, it will be a 0, then comma 1. He wants the area that has 1.5% of the distribution to the left. So it just put 0.05 right here. Not 0.05, 0.015. 0.1, that should give you the answer. All right. So that's the second feature that you would use in chapter 5. Let me go to another one. The test scores for the analytical writing section, particular standardized test, have a normal distribution with 3.7 mean and 0.88 standard deviation. What's the maximum score that can be at the bottom of 15%? So what would that be, guys? If I want to do the draw, it will be inverse norm. All right. I need area to the left at the bottom of 15%, so it will be 0.15. And here you don't put 0.1 because he gives you a mean and a standard deviation. It will be 3.7 and 0.88. B, so you get this number. B, between what 2 values does the middle 70% lie? Okay, let's see what the middle 70% is. This is 70% here. Okay, we have 30% left, guys. So 15% will be here, and another 15% will be there. So we need this one, which we already did. And the other one, we need this one. So that's already, we did that. It's 2.79. Now to find this one, what is the area to the left? I have a 70% and I have a 15%, so it will be 85%. So this one, guys, you do inverse norm, 0.85, and then you put the mean, and then you put the standard deviation. And that should give you the other answer, which is 4.61. All right. Next, let me clear the drawing. Same, another question similar to the one that I did. Okay, here. What's the mean and the standard deviation of the sample in distribution? If you're working with sample means, the mean will be the same as the mean of the original population, but the standard deviation will be the original standard deviation divided by the square root of the sample size, which is 244. So if you take 25, guys, and divide it by square root of 244, you should get this. All right, next. For a sample of n equals 62, what the probability of a sample mean being less than 24.3? So in this case, guys, is asking you to find probability of x bar less than 24.3. What is the difference between what we did earlier and now? It is what's going to happen, the standard deviation will not be the original standard deviation. You have to use sigma over square root of n. So if you do the normal CDF here, will be negative a million, 24.3. Mean is 24. And look, guys, what I'm going to do now, standard deviation. It's 1.24 divided by square root of the sample size. And what did he say? The sample size here is 62. So I'll just put 62. So that's how you work with the sample means. He gave you table 4 if you want to use it, but you can use normal CDF. Okay. This is not unusual because the answer is more than 5%, as you notice right here. Next. Okay. Another example on this central limit theorem chapter. The mean is the same as the mean. The standard deviation will be 60 divided by square root of 27, the sample size right here. Another question from section 5.4, just similar to what I did. Another question, and now I'm in chapter 6. You construct a 95% confidence interval with the population mean using random sample. The confidence interval is this. Is the probability that mu is in the interval 0.95? No, the meaning of the interval is with 95% confidence, we can say that the true mean is between 24.9 and 31.5. So that's what it means. It doesn't mean that the probability of that the mean will be there is 95%. It means that we are 95% confident that the true mean is between 24.9 and 31.5. That's what it says here. This kind of question, guys, will be the 10-15 second question that I'm talking about. If you have a confidence interval, how do you find the margin of error? You just subtract the lower part minus the upper part and divide by 2. How do you find the sample mean? You add them up and divide by 2. Same question. Now, he's asking you, he gives you a random sample of 35 home theater systems, has a mean price of 146, and assume the population standard deviation is 17. Okay, what does this mean, guys? This is very important to know which test or which function to use. When doing intervals, if he gives you the population standard deviation, you must use the interval. So if the population standard deviation, guys, is given to you, you use the interval. You provide sigma, you provide X bar, and you provide N, and you provide the confidence level, and you get it done. He's asking you to do a 90 and 95%, so you just do it one time for 90, another time for 95%. Let's go to the next one. Here he's asking you to find the critical value TC for the confidence level. I would use the table here. It's very easy to use the table. Watch, guys. He gives you confidence level 98 and size is 14. There you go. Let me clear this. This is 98 right here. And degrees of freedom is 14 minus 1, so 13. So that will be 2.650 right here. Draw. Right here. Okay. I'm not sure if you were able to see the table, but it popped up. Next question. Mouse. Okay. He's asking you to find a confidence interval, but let's see whether it is a Z or T. In a sample of 29 people, the mean commute time for work was 30.2. So this is X bar. And this is N. And the standard deviation was 7.3. He didn't say population standard deviation, so just feel free to label it as S. Once you label it as S, guys, it's no longer Z interval, it's T interval. There's a big difference between the T and the Z. We use Z when sigma is known, we use T when S is given instead of sigma. This is the interval. If you have the interval, guys, and you are asked to find the margin of error, you subtract the lower value from the upper one and divide by 2, you should get 3.3. I'll move on. Next. Let me just clear. Another question here. Okay. Let P be the population proportion. In a survey of 1,411 adults, 309 said that they were not confident that the food they eat is safe. What is the point estimate for P? It's a P hat, and P hat, guys, by definition is X over N. So you just take 309 divided by 1411, you will get 0.219. How do you find the Q hat? It's 1 minus 0.219, will be 0.781. Okay. So that's a very easy, short question. We good so far, guys? Any questions? Okay, thank you, Jessica. Next. Okay, in a survey, now we're doing the proportion interval, 1 prop Z interval. Just a friendly warning, this is not the order you're gonna see questions on the final exam. There are gonna be different orders for every single student. In a survey of 2,587 adults in a recent year, 1,209 say that they have made a New Year's resolution. Construct a 90 and 95% interval. So you go stat tests, 1 prop Z interval, you enter the value of X and you enter the value of N. Remember, X is a smaller one. So your X will be 1,209 and your N will be 2,578. And then you just enter the confidence level. You do it twice, guys, and you get, the higher the confidence level, the wider the interval. Now, I wanna bring one thing to your attention. What about if you see a problem like the following? In a survey of 2,587 adults in a recent year, 68% say they have made a New Year's resolution. How would you find X? If I give you the percentage, guys, to find X, you multiply the percentage by the total. So if I say, let's say 68% here, you just do 0.68 times the total, which is 2587. And you make sure that this is a whole number. If it is not, you round it to a nearest whole number, because the calculator will not accept X unless if it is a whole number. So if you get, for example, X to be 1207.7, round it to 1208. Otherwise, if you enter 1207.7, the calculator will not progress from there. Okay. I think that's chapter 6. We're in 7 now. Let me just clear. Minimum sample size. You have 90% confidence for the proportion. Her estimate must be accurate within 1%, so that's E. That is E. No preliminary estimate is available. What's the sample size? If no preliminary estimate is available, the sample size will be this, guys. 0.5 times 0.5 times ZC over E squared. Okay, do you know for 90% confidence what ZC is? I asked you to try to memorize this. It's 1.645. And E is what comes after within, which is 0.01. So you just do the math and get the sample size. You must round it up. See, it says round up to the nearest whole number. Now, what is the minimum sample size if a preliminary estimate is available? So we know that P hat is 36%. So the formula, guys, will be 0.36 for P hat. What is Q hat? It will be 0.64 times 1.645 divided by 0.01 squared, and round up. All right, next. Okay, we are in chapter 7 now. Use the given statement. Okay, it's just to find a complement, so greater than, the opposite to it is less than, and then select it right here. This should be a 10-second question, guys. Same thing. You need to know what type 1 and type 2 errors are. Type 1 is when you reject the null hypothesis when it is actually true. And type 2, when you fail to reject the null hypothesis when it is actually false. Here he says a furniture store claims that no more than 10% of its new customer will return to buy their next piece of furniture. So let's see, let's write the claim. No more means less than or equal to. P here. That's the claim. It is an HO. So what would be HA here? P is greater than 0.1. Okay, let's interpret type 1 error. Type 1 error, as I said, when you reject the null hypothesis when it is actually true. So a type 1 error will occur when the actual proportion of new customers who return is at most 10%, but you reject it. That's what it says. And a type 2 error will occur when the actual proportion, I'm reading the correct answer at the bottom, guys, who return to buy their next piece of furniture is actually not this, that, but you fail to reject the null hypothesis. Next. Let me clear here, drawing. A scientist claimed that the mean incubation period for the eggs of a species of bird is more than 44. More than 44, guys, is this. So it happens to be in the alternative hypothesis, as you notice. By the way, on the test, guys, if you see HA or H1, it is the same thing. As I told you, some Some statisticians label it with A and others with number 1. That is both referred to the alternative hypothesis. So does the claim represent the null of the alternative? Well, it represents the alternative hypothesis right here. How would you interpret a decision that rejects the null hypothesis? If you reject the null hypothesis and your claim is in the alternative, you support the claim. And that's what it says here. How do you interpret the decision that failed to reject the null hypothesis? If you don't reject the null hypothesis, then there is not enough evidence to support the claim. All right. Mouse. Next. Let me clear here. He gives you the p-value and then asks you whether you should reject HO or not. Well, if the p-value is less than alpha, guys, you reject HO. And if it is greater than alpha, you fail to reject HO. And he gives you 3 different alphas. So I'm just going to skip this one. Remember, this is the big deal for this book. P-value less than or equal to alpha, reject HO. P-value bigger than alpha, don't say accept HO, just use fail to reject HO. That's the highlight of this book. All right, next. Okay. Find the p-value for the indicated hypothesis test. He gives you a right tail test, and he gives you the test statistic Z to be 1.76 and alpha 0.05. He's not asking you to perform a test, it's just the p-value. Well, the p-value, guys, for your information, is the area to the right of the test statistic if it is a right tail test, to the left of the tail test statistic if it is a left tail test. Well, since it's right here, so we know it's an area to the right. So what is the, how do I find the area to the right of Z 1.7? It's normal CDF 1.76, a million or 1,000, whatever, and then 0.1. Why 0.1? Because I have Z here. And then you should get this. What's your conclusion? Alpha is 5%, that's less than alpha, we reject HO. All right, next. Okay, this is a question about testing the hypotheses. Let's see. In chapter 7, guys, you have 3 tests that you have to be aware of. You have Z-test, T-test, and prop Z-test. You use this one when sigma is given. You use this one when sigma is unknown, so he'll give you S instead. And you use this one to test the proportion P. These are for the mean. You test the mean right here. So let's see which one is going to be. He says, assume that the population standard deviation is 40, guys. So you know it's a Z-test. You go to stat, tests, Z-test. For HO, you enter the value, which is what, 285. You enter sigma, which is 40. You enter X bar, which is a mean score of 291. And you enter N, which is 78. And then before you hit calculate, you must choose the alternative hypothesis. And the alternative in our case, what is the claim? Mean score for the state's 8th grade on the exam is more than 285. So this is it, guys. So you choose this one and then hit calculate. I'll let you look at it before I move to the next screen. You will get the test statistic, you will get the p-value, and then you do the remaining steps. Okay, I'll clear. And then next. I know I'm going fast. Remember, this is just a review, guys. Use a t-test. Well, here he's telling you use a t-test. So there will be surprising to me if students go and use a z-test. It's telling you it's a t-test. But even if it doesn't tell me, how do I know it's a t-test, guys? Look, right here, watch. He gives you S. Once he gives you S, it's a t-test. The claim is mu is greater than or equal to 8,000, so that will be the one right here. Less than 8, so this is the claim right here in the null hypothesis. You find the test statistic, you find the p-value, we reject HO. And if you reject HO, you say there is enough evidence to reject the claim because the claim happened to in HO. You don't use the word support, guys. The claim is in HO and you reject HO, then you reject the claim. That should make sense to you. Okay. Next. And let me clear my drawing. This is another exercise. Okay, guys, you can disregard this part. It won't be critical value, it will be a p-value here if you see that on the test. But for this one, guys, you have to input the data and put it in L1 and then run a t-test. Input, you must select data. Then for mu0, you select 96,000. You write 96,000. Then for the list is L1. And then make sure to select your alternative hypothesis. Whatever he says test it is different from, so you select this one, press enter, and then hit calculate. You will get the test statistic and the p-value, guys. Any questions? Good, okay. Humane society claims that less than 70% of its households in a certain country own a pet. So less than 70%, if I go to, it's gonna be this. The null hypothesis will be greater than or equal to. And then he'll ask you to run a test. In a random sample of 500 households, 330 say they own a pet. So this is your N, this is your X, and it's gonna be a one prop Z test, guys. One prop Z test. For HO, you put 0.70 or P, I think it says P0. Then for X, you put 330. For N, you put 500. And then P1, you select the alternative sign, which is what? Less than, and then calculate. You will get, let me scroll down. Z is negative 1.95, p-value. Okay, what is alpha here? Alpha is 5%. So that's less than alpha, reject HO. My claim is in HA, we support the claim. There is enough evidence to support the claim. Any questions, guys? Okay, no questions. We'll move on. Okay, good. Next one. All right, we're in chapter 8 now. So let's see what's in chapter 8. Test whether mu1 is less than mu2 at alpha equals 5% level of significance for the sample data shown in the outcome. Assume populations are normally distributed and click the icon to view the data table. So if you see anything in blue, guys, you must click on it if it asks you to do so. Okay. He gives you S, guys. So that's a clue. It's going to be a two-sample t-test. So annotate. So this is going to be for from the S, guys, right here, you know it's a two-sample t-test. What's missing in this problem that I didn't tell you whether population variances are equal or not, but I didn't miss that on the final. So let's assume population variances are equal here. So when it comes to pooled, you select yes. I don't think I skipped that part, guys, but if I did in any problem on the final, it doesn't stay and state that, and you're sure it's two sample t-test, no pooled by default is no, but if it say, it should say, it should pretty much say. So here you use a two sample t-test, you enter N1, X1 bar, S1, N2, X2 bar, N2, and then you choose the alternative hypothesis, and then pooled yes or no, and then you execute the test. And let me walk you through the steps. You get, he didn't ask you for T here, just for the p-value. So this is the p-value, and then it's less than alpha, reject HO, and support the claim. Let me clear. Another one, let me see what's in there. Oh, two series. Let's see what the claim is. Do not assume, look what he says here. Do not assume population standard deviations are equal, guys. So you know what that means. Pooled is what here? Either he says population variances or standard population standard deviation. It's the same thing. So here pooled is no. And that's a clue for you. It's going to be a two sample t-test. But you have to put the data from city 1 in L1, data from city 2 in L2, and then when it comes to two sample t-test input, you select data. You choose L1, L2, you choose the alternative hypothesis, and which is what here? It's a greater than, and you hit calculate. Okay. All right, so that's the next one. This is a review, guys. It doesn't mean that you're going to have 3 or 4 questions from this section, but I put enough questions so then you can have enough exposure on the review for this part. That's an important section, guys. 8.2. Let me go to the next one. Oh, here's another one. Let me clear. He says sigma 1 square is different from sigma 2 square. Right away, pooled is no here. No, no, no. So you just put a no when you run a two sample t-test. You run a two sample t-test, you got all the information, guys. Make sure, he says the claim is in the null hypothesis, and mu1 is less than or equal to mu2, so which it's gonna be, doesn't show here. Let me show you. Mouse. Oh, I don't see B here. Oh, right here. Oh, I'm sorry. I didn't see it. I was looking for the correct answer. So this is the null and the alternative hypothesis, and then it's a two sample t-test, guys. Let's move on. Section 3, dependent samples. When the samples are dependent, it is the same person before and after some action. What you have to do, guys, is you need to do the differences. 215 minus 213 is a 2. 230 minus 229 is a 1, and then -4, and that's a 2, and so on and so forth. You put all of this data, guys, in L1, and you will be testing against 0. Now, a student emailed me recently and asked me if the differences are all positive, can I assume that I'm testing greater than 0? I said, yeah, likely the case. Or if all mostly negative, can I assume I'm testing less than 0? Yeah, it might be very much the case. But sometimes he can ask you if there is a change. A change, it doesn't mean positive or negative. It's just different from 0. If you want to see if the cholesterol has been lowered, you expect, just the numbers after you take the medication to be lower. So when you take a large number minus a lower number, it's going to be positive. So that explains why this is correct right here. That's the claim. So you guys, you put this in L1 and you run a t-test. Your mu0 will be 0. Your list will be L1, and you choose the alternative sign. And the alternative sign here is greater, and then you hit calculate. You will get T, and you will get the p-value. And then the p-value here, what's alpha here? 5%, so it's more than alpha. So fail to reject the null hypothesis, and if you fail to reject the null hypothesis, there is not enough evidence to support the claim. All right. I'll clear. Now in 8.4. Here, determine whether a normal sampling distribution can be used for the following. It can be used, if it can be used, test the claim about the difference between two population proportion P1 and P2 at the level of significance alpha. So he wants you guys to test that P1 is not equal to P2. So it's a two proportion Z test. Don't worry, we still have time to do 9 and 10. So HO guys and HA, we need to test that P1 is different from P2, that's the claim. And P1 equals P2. So it's two prop Z test. You need X1, N1, X2, N2, he gave him to you. And all you need, guys, before you hit calculate, make sure to select not equal to from the alternative sign. Z is 0.13, and what's p-value? It's gonna be huge here. Let me just scroll down. 0.894, more than alpha, fail to reject the null hypothesis. If you fail to reject the null hypothesis and your claim is in the alternative hypothesis, you cannot support the claim. And there you go, it's right there. Not enough evidence to support the claim. Well, next, let me clear drawing. Oh, chapter 9 now. So probably you need to pay attention to this since we've done it very recently. I haven't had a chance to do a lot of work on this. Correlation coefficient R. It is always between -1 and 1, guys. If it reaches -1, that means you have an optimal perfect regression correlation. And if it is 1, you have perfect correlation from the positive side. So this is the answer. I mean, for this question, guys, I shouldn't even give you more than 5 or 10 seconds to answer it. You either know the answer or don't know the answer. There is no math that you need to do here. Next. Okay, which value is a stronger correlation, guys? You have 0.719. Let me clear the previous one. And you have this. Well, guys, the -0.904 is stronger because it is closer to -1 than the 0.719, which is close to 1. So although it's negative relationship, but it is a very strong negative relationship. As I told you, the closer to -1, the stronger the relationship. The closer to 1, the stronger the relationship. And he gives you the answer as D there. Again, this is a 10-second question, guys. Okay, let's see here. He wants you to match the drawings with the description. This is a perfect. This is no correlation here. This is a quadratic, guys. If you remember from intermediate algebra, parabola, it's not linear. This is weak also. This is very good, but negative, and you can see strong negative. It doesn't have anything positive here or negative. Okay, next. Here. Click here to view the table. So you guys know what you have to do here. You have to put the age. Are you guys seeing the table that I just clicked on? Can you tell me if you see it or not? Oh, good. I didn't know that you could see the table. So you have the age should go to L1. The vocabulary size should go to L2. And let me remind you how to get R from this. I'm assuming your diagnostic is on. If your diagnostic, if your R doesn't show when you do it, this is what you guys do again. You press the second key. Let me just do. You press the second key on your calculator, then you press number 0. And then you scroll down to diagnostic on. And press enter twice. Then, after you enter your data in L1 and L2, you go to stat, then calc, then number 4, linear regression AX plus B. You will get the equation of the line if you need it. You will get R and you will get R squared. This is how you find R and R squared. Look at R, guys. It's very, very close to 1. So there is, you select from the drop down menu, strong positive linear correlation. Let's see if there are other questions. The second question, which one is the graph? Do you guys still remember how to get to the graph of the regression? Anyone remember what to do to see the graph? I showed you this. You do zoom and then select number 9, zoom statistic. Then once you look at your calculator, you compare it with which graph resamples what you see on the calculator and you select the graph. Well, for this one, it looks like this. One thing, guys, if you are to guess here, if I were you, I will cross this out right away, these two out, without even doing the calculator. How do I know that these two cannot be the answer? Can someone tell me why? Yeah, very good, Courtney. They're negative. It's a negative correlation, and my R turned out to be positive, so it can't be those. Remember, if your R is positive, your slope is positive, and if R is negative, your slope is negative. So if R is negative, the line is going to be pointing down, and if R is positive, the line will be pointing up. So now it's easy for you guys. It's between this one and that one. You just can select. What else? Is there more question there? Let me see. Oh. Interpret the correlation. As age increase, the number of words and vocab increase. Now he says, let me clear this one so you can see what we're doing next. Use the table of critical values for the person correlation coefficient to make a conclusion about the correlation coefficient. Okay, let's clear. This is the second one, the table right here. Watch. Alpha 0.01 here. What is alpha? Yeah, 0.01. Look, how do you use the table? Watch. N is 11 children, so we need N is 11, and alpha is 0.01, so we find this value here, critical value, 0.735. And look, it says the correlation is significant if the absolute value of R that you already found, which is 0.97, is bigger than this value, and it is bigger than this value, then there is strong evidence for correlation. So The critical value is 0.735. Therefore, there is sufficient evidence at the 1% level of significance to conclude. You don't need to type this. It's going to be, you just drop down menu. There is significant linear correlation. So if your absolute value of R is bigger than this value in the table, you say there is significant correlation. If not, you say there is not significant correlation. Next. Two variables have positive linear correlation. What can you say about the slope? The slope must be positive. That's what I just talked about. I'm gonna go move on. How to predict the Y value given the X value? You just plug in the X value into the equation. Is it appropriate to use a regression line to predict Y values for X values that are not within the range of X values? Let me tell you what I mean by that. Let's say, guys, your X values were this. And you have Y values here. And then you found the equation. Let's say the equation was 2.5x plus 7. If I ask to find the Y value when X is 5, feel free, guys, to use the equation. You just put 2.5x times 5 plus 7. But if I ask you to find the Y value when X equals 14, you should tell me that this is not meaningful. You cannot plug it into the equation. And you guys still remember why? Can you tell me why 14 doesn't work here? Because 14 is not within the range of values from 1 to 11, from the lowest to the highest. So if you have an option to say not meaningful, you choose not meaningful. All right. Next. We'll get into chapter 10 in this. Another one, to find the equation of the regression line. In order to find the equation of the regression line, you can put the data in L1, L2, and go to stat calc, linear regression AX plus B. So you can get it from there. A is the slope and B is the y-intercept. And he says round to 3 decimal places if you have to. So then you do it, guys, round to 3 decimal places. Here, you see predict the X values. Let's see if there is one non-meaningful. Okay, when X is 798, it says non-meaningful. Let's see why. Look at the table, guys. The highest number is 762, so you cannot go beyond 798, beyond 762. So that's why it's not meaningful. Same question, I'm gonna skip this. Here he's asking you about what do you think? There appears to be a strong positive linear correlation as the years of experience of the registered nurses increase, the salary tends to increase. All right. Coefficient of determination, R squared. Okay, let's talk about this, guys. Okay. To find R squared, unfortunately, you still have to put this data in L1 and that one in L2 and go to stat, calc, number 4. Make sure your diagnostic is on. And then you will get R squared. How do you interpret R squared? R squared is the percent of the variation of the Y variable that can be explained by the variation in the X variable. So it seems like this is the one right here. He says is the fraction of the variation in proceeds, which is NY, that can be explained by the change in X. Change or variation is the same word. Now the second question, guys, is the standard error of the estimate, which is S. Here's how you find S. You will go to stat, tests, linear regression t-test, and you run a linear regression t-test. It doesn't matter what you choose for the alternative hypothesis, greater, less, or it will give you S. You will get the value of S from the linear regression t-test. All right. And I'm gonna move to next. Now, chapter 10, guys. There will be questions from chapter 10. As I told you, there will be at least 2 questions from chapter 10. There are 3 sections, so you should expect at least 2 questions from there. Find the expected frequency for a given value of n and p. If you know the proportion and you know n to find the expected frequency or the expected value, just multiply n by p. So for this one, guys, 0.25 times 230, and you get the answer. But that doesn't really explain chapter 10. So let's move on and see what's next. Okay, now, this is a good question. A research firm claims that the distribution of days for which people are most likely to order food for delivery is different from the distribution shown in the pie chart. So this is the distribution of the percent of people who order food for delivery during the days of the week. But someone is making the claim that the distribution has changed. It's not the same as this. You randomly select 488 people and ask them what days of the week do you order food for delivery? And you got their information right here, guys. Test the claim. Okay, let's see. Let me just go to the mouse to close this one. All right. So as I told you, for goodness of fit test, guys, when you have more than 2%, it's a goodness of fit test. Your null is the distribution is as claimed. He says is as shown, which is the same thing. Distribution has changed. Your claim is in HA because he says test the claim that it's different. So it's in HA. Now the question is, how do you find the test statistic and the p-value? Let me remind you again, guys. So I'm gonna go to, let me show the pie chart first. I might need this. And now, okay. These are the observed values. You go to L1 and put the observed values in there. Now the expected values, guys, are a percent of the totals. You have 7%, you multiply each percent by the total, which is 488. So for Sunday, it will be 0.08 times 488. And you do the same thing for Monday. Then this is all gonna go to L2. These are the expected values. So observed in L1, expected in L2. What do you do next, guys? You go to stat, tests, and you look for this test, goodness of fit test, GOF. The GOF test is gonna ask you to check what's the observed and what's the expected. You already have L1 and L2, you don't do anything. But the only thing that you have to do is the degrees of freedom, guys. Can you guys tell me what's the degrees of freedom? You have to provide this before you hit calculate. You know what, you can enter it as a decimal if it doesn't tell you what to do. Just decimal with 1 or 2 places, that's fine. Good question. Degrees of freedom, I saw a student saying 6. I agree, it's a number of categories minus 1. Very good, guys, seem to be ready. So that's a 6, and then you do the test. And let me just go to the mouse. And you get chi-square, you get the p-value. Decide whether to reject or fail to reject. Well, the p-value is very small, guys. You reject HO and you support the claim because the claim is in HA. Let's go clear so I can have room for the next question. A researcher claims that the number of homicide crimes by season is uniformly distributed. Uniformly distributed, guys, means that all of them are the same. So you take the 100% and divide it by 4. So each one of them is 25%. It doesn't give you the percentages, but they are there. To test this claim, you randomly select 1,192 homicide from recent year and record the season when each happened. So uniformly distributed means the number of crimes in the spring, summer, fall, or winter are the same. State HO and HA distribution of the crimes is uniformly distributed. No, probably you'll tell me I told you that you should write distribution is as claimed. Well, here the drop-down menu says uniformly distributed, which means exactly as I said before. The claim is in HO, guys. And again, you want to do this, here is what you have to do. This goes to O. Observed values go to L1, observed. Expected. Actually, it's easier than the previous question. Expected value is going to be 25% of the total. So 1,192 is just take 25% of 1,192, 25% of 1,192. You don't have to do it twice, but it is the same. That goes to L2. Degrees of freedom. When you run the test, the goodness of fit test, it's 4 minus 1, which is 3. All right. So then you get the test statistic, the p-value, and you make decision based on that. I'm gonna move on. Clear drawings. Here he gives you a contingency table, observed value and expected value in parentheses for two categorical variables, X and Y. Use the table to complete parson B. Find the test statistics. Now this is the independence test, guys. It's a chi-square test. Okay, here's what I showed you yesterday and how to input your table. You don't need the expected value, actually. I don't need those. I only need the observed values. But he gave him to me assuming that I'm gonna do work by hand, but he doesn't know that we're using technology in this course. So to input the observed values into a matrix, here's what you do, guys. You press the second key, and then you press the X inverse key, which says matrix in blue. After that, you go to edit, and you enter how many rows and how many columns. It's 2 by 3. Remember, data columns, 2 rows and 3 columns, 2 by 3. And then you enter the values. You enter 30, you enter 45, you enter 55, you enter 16, 20, and then 14. And then after that, you quit. Then you go to stat, tests, chi-square test. Don't mix up the two tests. This is for the independence test, and the other one says GOF, goodness of fit test. Chi-square test, it's gonna tell you observed are in matrix A, confirm, expected are in matrix B, confirm, and then hit calculate. It will give you the test statistic right here. No degrees of freedom. Don't worry about it. The calculator can figure this out. For your information, if you want to know what the degrees of freedom for the independence test, it is number of rows minus 1 times number of columns minus 1. So since I have 2 rows, minus 1 will be 1, and 3 columns minus 1 will be 2. 1 times 2 is 2. But it's not gonna come up. All right. Next. Let me clear here. Okay, now we're doing ANOVA, analysis of variance, the last section. He gives you data from 3 sets, and the table below show the weights in pounds. The difference between this and what we did yesterday, guys, the columns, the data was given in columns. Here he gave it in rows. It's the same thing. If you can rotate this one, it will be in columns. The weights are classified according to vacuum clear type. At alpha equal 5%, can you conclude that at least one mean vacuum is different from the others? So as I told you guys, it's always mu1 equals 2 equals 3, but here he put the abbreviated names, which is okay. So mean 1 equals mean 2 equals mean 3. At least one of the mean is different. You couldn't choose any of those guys because they don't make sense. And this one, the at least, is done in the null, so that's wrong. So that must be the correct hypothesis. How do you run the test? Let me just do a draw. So this data here goes to L1, L2, L3, and then you go to ANOVA. This is the last test on your calculator, L1, L2, L3. And you will get F, which is the test statistic, and you will get the p-value. Here, F is huge, as you can see. P-value is 0. Then you reject HO, and where the claim is, it says at least one is different. So the claim is in HA, you support the claim. Okay, let's see what else. Same thing, another question. Let me see the data. Oh, here, guys. Oh, wow, 1, 2, 3, 4, 5. So here, guys, for this one, you have to do L1, L2, L3, L4, L5. And when you run ANOVA, you run ANOVA on L1, L2, L3, L4, L5. Okay. Finally, probably that's the last one. No, there is more. Let me just clear. We're almost there. Okay, what is this question here? Is there sufficient evidence to conclude that there is a linear correlation between court incomes and justice salaries? So it's about rho, testing the population correlation coefficient. It didn't say positive or negative. It says there is correlation. So you have to choose different from 0. And that's why he chose this one. So this data goes to L1. That one goes to L2. And you guys run a linear regression t-test. All you need to know before you hit calculate, your X list is in L1, your Y list is in L2. And before you hit calculate, choose the alternative hypothesis, which is different. You're going to get the test statistic, you're going to get the p-value, you're going to get R, you're going to get R squared, and you're going to get the equation, and you're going to get S if needed. So let me scroll down, show you what we have here. See the test statistic, the p-value, and p-value is less than alpha. Then, as I told you, to conclusion, if the p-value is less than alpha, you conclude there is strong evidence for that there is strong evidence that there is strong significant correlation. And if you fail to reject HO, you say there is not enough evidence to conclude that there is a significant correlation. And mouse, next. I don't know what, let me just clear here and see what this one is. National football, okay, let me see. Oh, it is an ANOVA test, guys, so, but it's a lot of data entry. You have to do L1, L2, L3, L4, and run the test again, so. What is this here? A length of a 17-year-old female upper arm is approximately normally distributed with the mean and standard deviation. Compute the following parts. Okay, let's see. Draw a normal curve. So your normal curve, guys, have to have 35.3 in the center. It can't be this one. It's between this and the, and it has to have standard deviation of 2.5. And you add 2.5 3 times, you will get almost to the end of the curve. So look, 2.5 plus 2.5 plus 2.5, guys, that takes you there. So this is the one. You can fire it up like this to see more of that. Then he says, shade the region that represents a proportion of 17-year-old female whose upper arm length is less than 33. Well, the 35, the mean is right here, and less than 33, it looks like this one would work right here. So that should be an easy question. C, suppose the area, this is from chapter 5, guys. Suppose the area under the normal curve to the left of x equals 30 is 0.0170. Provide two interpretations of this. Proportion of 17-year-old females with an upper arm length less than 30 centimeters is this, and he gives you another interpretation probability. The reason why I put this question there, so you know that the proportion, or the word probability, or the word proportion, or the word percent means the same thing, guys. Or area. Area to the left is a probability as well. Okay, let me go. You see, this is another question from chapter 5. Instead of saying a probability, it says proportion, but it's the same thing. Over 62, it means probability of x more than 62, which is normal CDF. 62 is the lower bound. A million is the upper bound. The mean is what? 56. And the standard deviation is 3.2. And you just do that. What proportion of hybrids gets 52 miles or less? Less than 52, you just do the same thing. And I'm almost done. Sample size. Determine whether the samples are dependent or independent. A data set included the daily number of words spoken by 60 randomly selected women and 60 randomly selected men. Well, they are independent, women and men, two different group of people, guys. That concludes this is another question from which chapter? Let me just look at it. Oh, now you have confidence intervals. So pretty much it give you the data set. So you put it in L1 and then just run a confidence interval. Remember, guys, when he doesn't give you the population standard deviation, you use a T interval. Usually when he gives you a data set, it's a T interval as well. Okay, we're done. I will be available for office hours later. I just need to take a little bit of a break. I've been talking for about 3 hours, guys.